based on programming method, we have incremental and absolute systems. Nowadays, in most of the CNC machine, you can use both the methods. Okay, so there is no separate CNC for incremental and absolute. In a same CNC machine, you can either go for incremental programming or absolute programming. Incremental NC system, the reference point to the next instruction is the end point of the preceding operation. So whenever you are taking a reference for upcoming movement, okay, you are taking the current position as a reference. That is incremental. So you will understand when we discuss the example. In case of absolute NC system, all moving commands are referred to one reference point, which is the origin and is called the 0 point. So here for every movement, you are considering origin as the reference, whereas in case of incremental, you are considering current position as the reference. So consider an example where you are considering only movement along x-axis or x direction. Okay, consider a drilling operation. You need to perform drilling of 5 holes. Okay, imagine there is a work part. So on the work part, you should drill 5 holes. In order to drill these 5 holes, okay, you have to move the XY table. Okay, here we are considering only movement along X direction. So in order to position for the first hole, okay, along X direction, the table should be moved for 500 units. So it may be 500 basic length unit. Okay, it should be moved for 500 basic length unit. So in order to drill the second hole along x-axis, from the origin it will be 700. Again for third hole, from the origin it will be 1300 basic length units. Or you can take any unit, it may be in mm also. Okay. Next, so for fourth 1000 units. For fifth hole 300. Okay, this is the example. This is the location of holes along x direction. Now suppose if you employ incremental programming. Okay, so in case of incremental programming, so initially you start from origin, that is 0. It is the origin. So you will first go for drilling the hole number 1. Okay, for this. So it should start from, the tool should move, or since it is a drilling, so you are moving the XY table. So it should be moved along X direction for 500 units. Then, so you can position the drill bit and you can perform a drilling operation. You will get hole number 1. Next, so that in the program, okay, in the NC program, it will be written as X plus 500. That means along X direction, X axis, in positive direction, it should move for 500 basic length units. Next, in order to drill the second hole, okay, now the reference will be previous point. So in order to drill hole number 1, already table has moved for 500 units along X axis. In order to reach the position of hole number 2, okay, it has to move only 200 further. Already the current position is at 1, that is already it has moved for 500. Now in order to move to position 2, hole position 2, so just it has to move for 200 units along X axis. Okay, we are not considering along Y axis, we are concerned only about movement along X axis. Okay, so that is the next command, X plus 200. That means you are taking this as a reference. So from here to here it will be 200 units along X axis. Next, so you should go for drilling hole number 3. Okay, for hole number 3, you are considering current position, that is at 2. Okay, now the table is moved to hole number 2. Okay, so now it should be moved to 3. So that means its distance is, so already it is 1300 from origin, but already, so it is at 2. That means 1300 minus 700. So the gap will be 600. It has to move for 600 plus 600. Next, now to position hole number 4. Okay, already it is at 1300. Okay, now it has to move backwards for 300 mm so that it will reach 1000 units. So this location. Okay, so that's why minus 300. Next, in order to move to 5. Okay, already it is at 1000 units. So in negative direction, so it has to move for, so 1000 minus 300, 700. So minus 700. Next, in order to reach the origin, minus 300. Okay, like this. In case of incremental ANC system or incremental programming method, you are considering the current position as the reference. Okay. Next, in case of absolute system, you are considering origin as the reference. This is the reference. Okay, in order to drill the first hole, okay, 500 along positive direction, x plus 500 for hole number 1. For hole number 2, again you are considering from the origin, so 700. For 3, 1300. For 4, 1000 units. For 5, 300 units. Next 0 will be origin. So that means, so you are considering origin as the reference whenever you are calculating distance. Okay, the table has to move in order to position the hole. So you are taking origin as a reference, that is absolute NC system. Whereas, so incremental NC system, we are considering the current position. Okay, or end of the previous segment from where tool or the work table will move. Okay, this is the difference between incremental and absolute. Okay, both have their own merits and demerits. Disadvantages of incremental system. In case of an interruption, that means because of various reasons. Okay, if you need to stop when the program is running. Okay, in case of interruption, the operator manually moves the tool holder, exchange the tool, and has to return the table to the beginning of the segment in which the interruption occurred. So this is a problem. So since there is a problem, okay, if you are manually moving the tool, okay, so you cannot move to the previous segment exactly. Okay, so because of that reason, you should start from the beginning once again. So tool or XY table. Okay, so in case of CNC machine tool, okay, so tool will move without removing material. So to the point till it reaches the point of interruption. So after that, it will start removing material. So that is a disadvantage. It is impossible to bring the tool manually precisely to the beginning of the segment in which interruption occurred. Okay, if you try to bring that by manually moving, okay, there will be some error. It may be error of 0.001 mm. Suppose if you are working on getting accuracy to that level, even if you are not able to move it, okay, so within that value, so it will be a problem. Okay, considering that, so if there is an interruption, so you should start executing the program from the beginning. That means there will be some unnecessary movement where material has been already removed. Therefore, operator must restart the part program and repeat the entire operation prior to the interruption point. Next, advantages of incremental system. Inspection is easy because, so if you add positive values and if you subtract with negative, so finally you will get 0. So easily you can inspect, so whether you have taken correct incremental positions or not. Okay, so so its value should be 0. So 500, 700, 1300 positive values, negative values also 1300. So it will be 0. There will be a balance. Mirror image program for symmetric systems. Suppose, so if you are working on symmetrical models, okay, then, so if it is 500, 200, 600, next minus 600, minus 200, minus 500. So like that, so you can write the program. So if you write for half, remaining half you can so replicate, so with a reverse sign. Okay, that is also possible for symmetric system. These are the advantages. Next, in modern CNC systems, So both you can program using incremental and absolute methods. Even in our college also, so we can do programming using incremental and absolute programming methods. Next, control loops. Okay, so based on control system, so we have one more classification: open loop and closed loop systems. Okay, so this is the representation of open loop. So this is a familiar thing. So in many courses already we studied about closed loop and open loop control system. Okay, in case of open loop, so usually we prefer to use stepper motor because there is no feedback. Okay, so we rely on stepper motor. So it will work on a particular relation. Okay, if you give one pulse input, that will result in a movement of one basic length unit, so that we know. Okay, in case of stepper motor, if you give one pulse input, that will result in a movement of one step angle. Okay, so we can divide. You get stepper motors with different step angles. It may be 1.5 degree, or it may be 3 degree step angle. Okay, or it may be 6 degree step angle. Like that, you will get stepper motors with different step angles. Okay, so suppose if you get a stepper motor, so which is having 3.6 degree step angle. Okay, so that means for one pulse input, you will get a movement of 3.6 degree. Okay, so similarly, if you give 10 pulse input, it will result in a movement of 36 degree. If you want to get one complete revolution, you should give an input of 100 pulses. Okay, so like that you will get stepper motors with their step angles. So here in case of open loop, so stepper motors are preferred because, so here if you are expecting some motion, if you give one pulse input, so you are having an expectation that it will result in a rotary movement of one step angle. Okay, depending on the pitch, you will get the linear movement. So here input to the motor is in the form of pulses. Then so it will result in rotation of the gear. Then it will, with the help of lead screw, you can get the linear movement of the table. Okay, so here you are not using any feedback devices. You are not using sensors to measure position of the lead table. Okay, next, in case of closed loop, okay, so DC motors are used. So here again for the motor, so you are giving input in terms of pulses. Okay, so there will be a comparator. So it will consist of feedback devices. So encoder is a position feedback device. Similarly, you will get velocity feedback devices like tachometer, okay, which is used to measure speed. Okay, so in this case you have a feedback loop. So and comparator, the function of comparator is, so it will compare the input value, input pulse, and it will compare that with, so the input it got from the encoder. Okay, so input to the motor and feedback signal from the encoder in the form of pulses. Okay, so these two will be compared. If there is a difference, then corrective action will be taken. So if there is no difference, so we can continue with the same level of inputs. Okay, otherwise you may have to increase or decrease the pulse frequency. So digital to analog converter. Okay, so because, so in comparator, so it may be in terms of numbers. Okay, so then it will be converted into a analog signal, digital to analog conversion. Then so DC motor will receive electric signal, that is analog signal. Next again gear, lead screw. Okay, the position of the table, so will be identified using a sensor called encoder. It is a position sensor. You will get position feedback. So next, when we can go for open loop, when we can go for closed loop. Okay, so if you are confident about the output for the given input, you can go for open loop. Okay, if you don't have confidence, then you should go for closed loop. Okay, usually closed loops are preferred than open loop systems. Okay, and there is one more criteria. So usually for constant load applications, okay, we can go for open loop. For varying load application or varying torque application, so we should go for closed loop. That means in case of machining, for drilling you can go for open loop. For milling, so you should go for closed loop. Okay. Here we are continuously varying the feed. Okay, feed depth of cut. So you are varying that. So depending on that, the load applied to remove material, so also will vary. Okay, so in that case, if you go for using stepper motor, that may result in loss of few steps. Okay, then again it will become inaccurate. Okay, so stepper motors, so if there is varying torque, for varying torque applications we don't prefer stepper motor. For constant load applications we prefer stepper motors. Open loop system, no feedback and controller has no information about the effect of the signals that it produces. Uses stepping motors for driving the slides. Slide means it is a sliding movement. Okay, so relative movement will be of sliding motion. So that's why we are considering those mechanical elements as slides. A stepping motor is a device whose output shaft rotates through a fixed angle, that is called as step angle, in response to an input pulse. So it may be if the step angle is 1.6 degree, that means if it receives one pulse, it will result in a movement of 1.6 degree rotation. Okay, like that it will work. Next, closed loop system, it measures the actual position and velocity of the axis and compares them with the desired references. In order to get position and velocity feedback, we use sensors. Encoder is one position sensor. Similarly, tachometer is used to measure this velocity or speed. NC systems, both the input to the control loop and the feedback signals may be a sequence of pulses, each pulse representing a BLE. Okay, even so from the encoder, you are getting a feedback signal that will be also in the form of pulses. In case of closed loop system, the digital comparator correlates the two sequences and gives a signal representing the position error of the system, which is used to drive the DC servo motor. Okay, next. So consider a problem. Okay, it is the application of concepts which we discussed in previous class and this class. Okay, a stepping motor of 200 steps per revolution is mounted on the lead screw of a drilling machine. The lead screw pitch is 0.1 inches. What is the basic length unit of the system? Then, if the motor receives a pulse frequency of 2000 pulses per second, what is the linear velocity in inches per minute? Okay, so it is a very simple problem. Okay, it will reflect your understanding of concepts. Okay, so read the problem and try to give answer for first question. Okay, I think you know the meaning of pitch. Okay, what do you mean by pitch?
The distance between the two amplitudes of the waves.
Same points on the thread. Okay, but general meaning other than that. So here, so pitch 0.1 inches means. So if there is one revolution, okay, that will result in 0.1 inches linear movement. Okay,
yes, sir. Linear, yes, sir.
If there is one revolution, it will result in a linear movement of 0.1 inches in case of lead screw. Okay. So now based on this, find out basic length unit. Okay, what is the value of basic length unit? Okay, yesterday we considered one more relation. Okay, one basic length unit, so will be approximately equal to one pulse, and that will be approximately equal to 1 bit. Okay, BLU will be equal to one pulse, that will be equal to 1 bit. Okay, using that also you can find basic length unit.
That is 0.0005.
0.0005. Okay, so now, okay, for second question, Sangamesh or Dhanlakshmi should give answer. Okay, so first,
Yes.
basic length unit. So here you have 200 steps per revolution. Okay, that means motor should receive 200 pulses. Okay, if it receives 200 pulses, then it will result in a movement of 0.1 inches. Okay, pitch value 0.1 inches means for one revolution. So there will be a linear movement of 0.1 inches. In order to get this one revolution movement, so it includes 200 steps. That means, so it is working at a step angle of, so 360 by 200, that will give you step angle. It may be 1 point something, okay, 1.67 like that you will get, okay, that is the step angle. So if there are 200 steps, then it will result in movement of one revolution. Okay, then for each step, that means for each single pulse input, there will be only one step rotation, okay. So for this one step rotation, what is the linear movement that you have to find out? So that you can find out like 0.1 by 200, that will give you basic length unit. Okay, next, so what is the answer for second question? Okay, now you know basic length unit. That means, so that is an indication for one pulse. Okay, there will be a linear movement of one basic length unit. So we know that value 0.0005. So that is the basic length unit. For one pulse, there will be a linear movement of 0.0005. Then for 2000 pulses, how much? That you have to find out. So what is the value? So your one pulse is 0.0005 inches if there is linear movement. For 2000 pulses, 2000 times of that. So 2000 into basic length unit, that will give you linear velocity. Okay. Usually that will be in terms of seconds. Okay. Then you have to convert it into minute. Okay. That conversion you should do. So this is the answer. Okay, for basic length unit, so you know for revolution it will be 0.1 inches. Okay, next, so for one step, so one step is nothing but, so you are going to get one step rotation for one, okay, pulse. So for one pulse, what is the linear movement? That itself is basic length unit, that you can find 0.1 divided by 200. So there are 200 incremental positions which will result in one revolution. Similarly, in the linear movement also, so in order to achieve this 0.1 inches linear movement, so there are 200 incremental positions. It will start from 0.0005. Okay, next it will be 0.001, next 0.0015, 0.002, like that. So there are 200 positions. So in between 0 and 0.1 inches. Okay. Next, so in order to find this linear velocity, so you know per pulse, okay, you can get 0.0005 inches movement. Next, for 2000 pulses, you are going to get 2000 into 0.0005. So next you will get velocity in terms of inches per second. In order to convert it into minute, you are multiplying it with 60. Then you will get inches per minute. Okay. Next, one more problem. Okay, this is the last problem. Okay, if you give answer for this, I will wind up this class. Okay. A DC servo motor is coupled directly to a lead screw. So we are using lead screw to convert rotary movement into linear movement. Rotary movement of the motor into linear movement of the table. So gears are used in order to increase or decrease. So in order to step up or step down. Okay. So usually it is used to step out. So you can have gear ratios. If you want to get greater linear velocity, you can make use of gears. Okay. So a DC servo motor is coupled directly to a lead screw. That means here you are not using gears. Directly you are coupling shaft of the motor to the lead screw. A DC servo motor is coupled directly to a lead screw which drives the table of an MC machine tool. A digital encoder, which is a position feedback device, which emits 500 pulses per revolution, is mounted on the other end of the lead screw. If the lead screw pitch is 5 mm and the motor rotates at 600 rpm, calculate the linear velocity of the table, the basic length unit of the MC system, frequency of the pulses transmitted by the encoder. Okay, so calculate for first sub question, linear velocity of the table. Okay, read the problem and give the answer. Read the problem, solve it and give the answer. Okay, so everyone must give answer. So there are 3 sub questions and there are 3 students. So ಯಾರಾದರೂ ಕೊಡಬಹುದು. First ಕೊಟ್ಟವರು, so then remaining will give answers for 2 and 3. Okay, if you have solved, you can unmute yourself and you can give the answer.
Sir, 15 into 10 power 5 mm per minute.
How much?
That's 15 into 10 power 5.
50 into 10 power
5 mm per minute.
mm per minute. Okay, any other answer?
Sir, basic length unit is 0.01 mm.
Linear velocity will be 3 meter per minute.
3 meter per minute. Okay. Next. Last question. Okay, frequency of pulses will be pulses per second. That is the unit for third question, sub question. So you have to find out pulses per second. Okay, if you have solved, anyone can give answer for third sub question.
It is 5,000 pulse per second.
Okay, so you know, so 600 revolutions per minute. Okay, so for each revolution, so there are 500 pulses. So 500 into 600 will give you, so pulses per minute. Okay, divide that by 60, you will get pulses per second.
Yes,
Okay, like that you have to find out.
5,000 pulse per second.
5,000 pulses per second. Okay, for the first one, so linear velocity of the table. Okay, so you know, so if we are considering it for minutes, okay, per minute there are 600 revolutions. Okay, so pitch 5 mm means for each revolution there will be a linear movement of 5 mm. Next, for 600 revolutions, 600 into 5, that will give you the linear movement. Okay, that is the linear velocity of the table. Next, basic length unit of the system. So, you know, for one revolution, there will be 5 mm, 5 mm linear movement. Okay. Next, so in order to achieve this one revolution, what is the input you are giving? You are giving 500 pulses. For 500 pulses, you are getting 5 mm linear movement. Now what you should find is for one pulse, what is the linear movement? So that will be given by 5 divided by 500. Okay, so that is 0.01 mm. Next, last one I told you, like that you have to find out. Okay.